About 60% of subsidence insurance claims are tree-related, and last year claims amounted to around £300 million. In this month's Property Services programme, we ask whether all these claims are really necessary.
Hello and welcome. As you've heard, this month's programme is all about foundation damage caused by trees. The programme's been contributed by leading arboriculturalists O'Callaghan Associates. They've recently been involved in research which questions the effectiveness of current methods used to assess tree damage. They argue that millions of pounds has been spent unnecessarily. Philippa Lamb has been talking to Dr. Dalga O'Callaghan and Mike Lawson from O'Callaghan Associates, who explain their findings. We'll also be hearing from Mike Crilly, a geotechnics expert from the Building Research Establishment.
In the early 1970s, the insurers of domestic properties first introduced subsidence and heave cover onto domestic policy insurance. Since then, we've noticed a considerable increase in the amount of claims for subsidence and heave damage. Now, most of that is not attributable to technical causes. It has to be attributable to a change in attitude of the insured and of the professionals involved in the investigation of such claims. Damage that was considered to be fairly minor prior to the introduction of subsidence and heave cover is now seen as being cause for concern.
Foundation movement has many possible causes, including chemical attack, frost heave, mine workings or natural cavities, consolidation of poor or made ground, soil erosion, floor slab movement, and changes in moisture movement in shrinkable clay soils.
Mike Lawson, Dalga O'Callaghan, welcome to the programme. Mike, if I can start with you first, can you explain for us what effect trees have on the water-bearing content of shrinkable clay soils?
Well, remember it's always an indirect action, but firstly they can take the water out of the clay soil, changing its volume. This is termed subsidence. However, also removing a tree can lead to rehydration. This is called heave. But we should also remember that these two terms are really both the same thing, ground movements.
The currently accepted approach to assessing whether a tree has caused foundation movement revolves around the concept of water demand. Different species of tree have different requirements for water depending upon their species and height.
Now, Dalga, you've been doing some research into tree roots and foundation failure, haven't you?
Yes.
What have you found?
Well, we've done a number of researches. First and foremost, we worked closely with the Meteorological Office and looked at their MOREX data. We have worked closely with the BRE in assessing foundations and depths and so on. We've done extensive literature surveys, including one for English Heritage, on the effect of roots on buried remains, and we have done hundreds of site investigations. As a result of that, we can say a lot of the data that is available is being misapplied and misinterpreted. Specifically, the term water demand of trees, which really has no bearing on arboricultural or biological matters. It is of no significance whatsoever.
Mike, how have your findings actually affected the rule of thumb approach to measuring distance from tree to distance from damage?
We can make that very easy. There's no rule of thumb. Effectively, the data that was collected established that by digging trial pits away from trees, roots may be found at various distances. However, this has no relationship with the distance to damage relationship normally associated with building failure. For instance, the maximum distance of root extent for willow is 40 metres. However, 90% of all damage is within 12 metres. That's surely instructive for us. Also, there was no collection of the data about the type of clay soils or the depth of foundation. So we really have to be very careful when we make these rather vague generalisations.
Dalga, what are the positive benefits of trees?
Well, there are many. One could list hundreds, but I'll go through the key ones. But what we've got to remember first is the number of trees we have in our towns and cities. By our estimate, there's somewhere between 90 and 150 million trees within built-up areas throughout the United Kingdom, and that's a lot of trees. And they have a vital role to play. For example, they help their air conditioners. They produce oxygen, they absorb particulate matter, they clean the air, they absorb sound, and very importantly, they sequester carbon. They take CO2 out of the air and they clean our cities. The urban forest, in fact, is extremely significant in terms of global climate control. And another thing one must bear in mind is that trees have been shown to add up to 10% to the real estate value of property.
With inadequate information, what should the surveyor do when faced with a foundation problem that may be tree-related?
Not all damage is tree-related. There are causes both within the building itself and related to the foundations that can cause damage but aren't related to the trees. So it's important to ensure that trees are the cause before carrying out costly and possibly unnecessary remedial measures.
The susceptibility of buildings to crack as a result of ground movement depends on a number of factors which need to be investigated. BRE Digest 251 provides guidance on how to assess damage to low-rise buildings with reference to progressive foundation movement. Part of the investigation involves classifying the damage category. The damage categories set out by BRE relate to visible damage to walls and the ease of plaster and masonry repairs. There are 6 categories.
Category 0, hairline cracks less than 0.1 millimeter where no action is required. Category 1, fine cracks up to 1 millimeter which can be treated during normal decoration. Category 2, cracks up to 5 millimeters wide. Here cracks are easily filled, although doors and windows may need to be eased and adjusted. Category 3, cracks 5 to 15 millimeter wide, or several of, say, 3 millimeter wide. In this case, cracks need to be patched by a mason. Doors and windows stick, and service pipes may fracture. Category 4, cracks of 15 to 25 millimeter. Such extensive damage requires the breaking out and replacement of sections of walls. Floors will slope noticeably, walls will lean or bulge, and services will be disrupted. Lastly comes Category 5, where typical cracks are greater than 25 millimeter. Here, major repairs will be required involving partial or complete rebuilding.
Of the BRE damage classifications, categories 0 through to 2 we would consider to be purely aesthetic damage. And in a survey that we did in the late 1970s, we found that about 70% of damage related to foundation movement fitted within those 3 categories, which means that most of the damage related to foundation movement is actually aesthetic damage. For damage in category 2 or less, it's often very difficult to identify the cause with any degree of certainty. Therefore, we tend to the opinion that it's unnecessary to carry out expensive remedial measures for that category of damage unless there's firm evidence to suggest that the damage is going to progress far beyond that level.
Having assessed the nature of the damage, the next step is to decide whether the cause is foundation movement and whether it will get progressively worse. If a clay subsoil is suspected and trees are implicated, BRE recommend the following investigations.
First, investigate the subsoil using trial pits to reveal the depth of foundations, the presence of clay, and the presence of fine tree roots below the foundations.
Dalga, could you explain how tree roots actually develop?
Basically, there is a misconception. People think that tree roots tend to grow down into the soil and to depth. In fact, this is not the case. The majority of tree roots are found in the upper 600 to 750 millimeters of soil. A maximum depth for a tree root would be 2 meters, but that would be less than 10% of the rooting volume of a tree, and then only in exceptional circumstances. They tend to grow out and wide, far beyond the drip line of the tree in many cases, and in some cases further than the height of the tree outwards. So the point we've got to bear in mind here is that 90% of the tree-related subsidence claims will be caused by less than 10% of the root volume of the tree.
Mike, what's the significance of the very fine roots that we need to check for when excavating trial pits?
Well, the difficulty is we have to be very careful because we define roots in a rather poor manner. A root to a surveyor will be a large woody object, generally hand or finger at least thick. There are large woody structural roots, there are woody roots that are just developing, and then the non-woody and what you would term wrongly the feeder roots, the very fine hair-like structures. The majority of the water uptake is by the very fine roots, and really it takes arboricultural advice to try and determine if these are present in a trial hole. It simply isn't enough to look for the large woody section, and trial holes invariably may miss a majority of the root system in any event.
So does that mean that if you don't find these fine roots in your trial hole, the tree isn't a problem?
Absolutely not. The spread of roots is absolutely asymmetric. The roots will go following the easiest path, and so the likelihood of finding trial hole roots is rather, well, it's rather rare or unusual. You can miss the whole point by saying we did not determine any roots of the species of tree present in this particular trial hole. You have to be very thorough, and really that needs arboricultural expertise.
Trial pits should also establish whether desiccation of the soil has occurred. This is important because an assessment of potential shrinkage of the clay and of the hydrological conditions can help to identify if tree roots are a problem for the building, particularly if it's on shallow foundations.
Continuing with recommended investigations, the surveyor should try to ascertain the history of the site and building, together with dates of observed movement and damage. The surveyor should record the position of the species, the approximate age of all nearby shrubs and trees, and the position and condition of nearby drainage. Damaged drainage can radically alter the subsoil moisture content and wash away fines.
Now, Mike, apart from drainage, what else affects soil moisture?
Well, crucially, if I can return back to that point, the various constituents of the soil will affect how the water enters the soil. The gravel, sand and clay contents have an enormous influence on rehydration. Many surveyors call soils clay, which actually aren't. But separate from that, hard impermeable surfaces can be crucial, as can the layout of roads, the highway, the pavement. The use of the garden, whether there is other vegetation, lawns can have an enormous impact. The structure of the soil, compaction. There are many, many ways, and many ways in terms of detailed analysis, that we can determine how water may enter or leave the soil.
Doug, how easy is it to determine whether a tree is going to cause progressive foundation movement in clay soils?
It's not very easy at all if one considers the variables that we have to contend with. We have, to say the least in Britain, a very variable climate. We will have variation in the soil types. We will have various foundation types depending on the building we're looking at. And trees themselves have an inherent genetic variability, and they are also dynamic. They move, they grow. Therefore, it's very difficult, if not impossible, to predict at any stage whether a tree will or will not cause damage to a building. This is usually decided after the event, when a failure has actually occurred. Then we can ascribe it to a tree or not.
BRE advised that if damage is no more than Category 2, then measures which include removing trees and underpinning are unwise until the progression of damage is confirmed. This should be done by taking measurements over a period of time. And often it's necessary to monitor the damage for at least 1 year to fully understand the nature of the movement.
On the basis of BRE's experience with trees and shrinkable clays, we've found that it's relatively uncommon for damage which occurs following a drought period to actually turn out to be progressive in the longer term.
BRE also advised that buildings can be safely sited close to trees on shrinkable clay soils, but only if the foundations are adequate. This means that it's necessary to take the foundations below the existing or probable zone of desiccation or root growth. These zones can sometimes extend as far as 5 meters.
Often, deep strip foundations are used when building next to trees or where trees have been removed. BRE state that strip foundations of more than 3 meters deep are undesirable for 3 reasons. 1, they are uneconomical compared to the board pile solution. 2, trench instability can lead to significant construction and safety difficulties. And 3, there is a danger of horizontal foundation movement when large vertical areas are subject to differential lateral pressures resulting from either shrinkage or swelling of the clay. As a result, for depths over 3 meters, piled foundations should be considered.
Where trees or shrubs have been removed prior to building, there's a risk that ground heave will occur as the soil resumes moisture content. The rate at which the ground will recover is very difficult to predict, and where there's any doubt that recovery is complete, then piled foundations should be used with suspended beams and floors. BRE Digest 241 provides guidance on the use of piled foundations for low-rise buildings on shrinkable clay soils. In the few cases where existing buildings are badly damaged by trees, the remedial action depends on the relative ages of the tree and the building.
Dalga, what sort of action is required if the tree is older than the house or the building?
Well, we're back to the variables I mentioned earlier. For example, if you have a silver birch some distance from a house, probably no action at all. However, if you have a very large, mature oak tree, you have no choice in that situation but to fell the tree and then cope with the result. It's futile, and there's no precedent to say you should phase the removal of the tree and attempt to stabilise the soil in some way, and nor is there any precedent for the fact that pruning or crown reduction will make any difference. You remove the tree and you cope, and that requires an integration of a number of professionals, engineers and arborists working together to come to the solution.
So conversely, what if the tree is younger than the building?
Well, I just go back to the previous answer. There are a lot of variables involved, and this is a matter where you do need sound arboricultural advice. Because of the variations and the variability, it is site-specific, it is species-specific. You need that advice, and engineers and surveyors need that advice from a professional arborist.
So Mike, to sum up, what's your advice to surveyors? What should they do?
Obtain the most professional arboricultural advice they can from the consulting sector, from the non-contractual sector. We found ourselves in a position where contractors with an interest in felling and pruning are carrying out the expert analysis in tandem with the surveyor. That surely is wrong. We can do a great deal in terms of education. People are, when they're moving into their new home very often, delighted and determined to reformat the garden. This means many new trees, many new types of trees, often inappropriately planted. Take expert advice from the various professionals and understand your subject.
Dalga, Mike, thanks very much indeed.
Thank you. Thank you.
Well, that brings us to the end of the programme. You'll find more details of the publications we've referred to contained in your study pack. But for now, from all of us at TEN, goodbye.